So students, now we focus on chapter number 3, that is artificial construction material. So in chapter 1 we get the overview about what are the different types of construction material, in which we classified the construction material in natural construction material, artificial construction material, advanced construction material, process construction material, from which we are going through the artificial construction materials. So this is the third chapter. So here it is a introduction to the artificial construction material. So the building material is any material used for the construction purposes, mainly naturally occurring substances such as clay, sand, wood, rocks. Then these are the nothing but the natural construction material, and some of the artificially or the man-made construction material has been utilized for the different kinds of constructions. So these are nothing but the bricks, blocks, concrete, metal, glass, ceramic, plastic foams, then cement composites are known as artificial construction materials. Then first artificial construction material, that is a brick. The constituents of the bricks are the earthen material. The civil engineer are really required to become a brick makers, but they should be familiar with the sources and how they are constructed. With the growing industrialization and development of the country, the demand of the brick also increases. The major problem facing for the brick industries are increase in the production, soaring of prices, and how to improve the quality of the bricks. So the quality of the brick depends upon the quality of the raw material and firing techniques. As we know that during construction or the manufacturing of the bricks, the temperature rises up to the 1400 to 1500 degrees Celsius. So these are the biggest problem, how the silos or how the kilns has to be prepared for manufacturing of the bricks. So in India there are three major types of soil deposits which are generally used for the manufacturing of the bricks. First, that is alluvial soil, then second black cotton soil, and third the red soils. Okay, and generally no, we are using the red soil because in our state the red soil is available in a huge amount. So red soil is utilized to manufacture the bricks. Okay, then the black cotton soil overlying Madhya Pradesh, part of some Maharashtra, then Gujarat. The black cotton soil is mixture of various clay minerals and mono promilo sorry Montmorillonite group. Okay, then red soils occurring in the region of Mysore, Assam, Madhya Pradesh, Maharashtra. These soils consist of kaolinite group, as like a black cotton soil included in the group of Montmorillonite group, and in red soil it is included in kaolinite group of minerals. Out of these three, the alluvial soils are the best for the manufacturing of the bricks. The earth of following physical properties are the most suitable for the bricks manufacturing. First clay, then second clay plus silt. The clay having percentage about 20 to 30%, and clay and silt is about 40 to 65%. In general, alluvial soil containing 17% of clay, 30 to 35% of silt, and that's why it can be utilized for the construction of the bricks. But that is available in only Mysore, Assam, or the Madhya Pradesh. And that's why we cannot get this, okay, easily. Then what is a conventional brick? Conventional brick is dimension of conventional brick is vary from 210 mm to 250 mm in length, and 100 to 130 mm in width, and 75 to 100 mm in thickness. And then the most common size of the conventional brick utilized is 230 by 114 by 75 mm. The figure indicates the conventional brick. Due to the size, these bricks are called as a conventional brick. They are in big in size, okay, as compared to the normally whatever the 4-inch brick we are utilize. Then property of constituents of brick. First, shale. It is a natural soft rock from which clay is produced by decomposition of the rock. Bricks are also made up of only shale. Then alumina 20 to 30%. It is the main constituent. It makes a clay. Plastic makes paste moldable, and excess alumina makes the brick shrink or wrap during the drying. So alumina is the best constituent in a brick or in also in constituent of cement. If alumina is present, it will use the plasticity to the brick or the cement. Then silica, sand or silica in appropriate quantities are added to a clay for manufacturing of the brick. It is hard cementing material and it prevents from the cracking. That's why silica, alumina, these are generally utilized in cement manufacturing also, and it is also utilized in the brick also. So this is the percentage or the composition of the brick. Alumina 20 to 30%, silica 50 to 60%. As alumina gives the plasticity, silica gives the strength. Then lime, it is generally less than 5%. Then 0.1 or the 0%, that is a magnesia, and iron oxide, that is a 5 to 6%. Types of bricks are the conventional, or it is also called as a traditional brick, which is a size ranges from 230 mm, sorry, 230 by 114 by 75 mm, or it can be converted to the centimeter, that is 23 by 11.4 by 7.6 centimeter. Then standard or modular size, that is the 19 centimeter by 9 by 9 centimeter. Bricks are classified as per the manufacturing process, that is hand molded and machine bolted. Okay. Then bricks are classified as per the quality and utility, that is first class, second class, third class, and fourth class. Uses of bricks. Bricks are used in masonry construction, that is wall construction. Then bricks are utilized for the brick lintel construction. Then bricks of bats of bricks are used in a concrete and a foundation work. So sometimes it is also used for the completion of the plinth work. Then in flooring, in construction of the brickwork, then in many embankment wall construction, foundation construction, the bricks are utilized. What is the classification of burnt clay bricks? The classification is as follows. First, the classification of burnt clay bricks. The bricks may be classified as a by quality, sand faced, rustic, and multicolored. Then second, by manufacturer, handmade, machine made, and molded. Then by utility, common, building brick, facing brick, paving brick, fire brick, hollow bricks, heavy duty brick, or engineering bricks. So these are the some of the classification of the bricks for the burnt clay brick. Then class, first class, second class, third class, and fourth class, in which we can include the bricks of different nature and their properties. They are sound, well burnt, and rectangular in nature. Then surface clean, smooth, and no cracks are observed. Hardness, that is very hard. Sustainability, that in phase of work of building and monuments. Second class bricks are generally having a nature of well burnt but with the irregular shape. Spots are observed on the surface, then they are hard. Then ordinary building work, or it can be utilized for the ordinary building work or for the cheaper construction. Then third class, that is underburnt, then having a rough and distorted edges, slightly soft in bind in building, not subjected to the heavy rains. Okay. Then fourth class, these are the worst in class. These are overburnt. Okay, that's why many spaces or the gaps can be easily observed. Many holes are easily observed. These are very hard but not durable one, and their lives also very less. Then it can be utilized for the road metals and as an aggregates for foundation, concrete, as a railway ballast. So following is the classification of burnt clay bricks. As we discussed, they are classified by the quality, that is a sandfest, rustic, multicolored, then by manufacturings, handmade, machine made and molded, then by utility, common or the building bricks, facing bricks, paving bricks, fire bricks, hollow bricks, heavy duty bricks and engineering bricks. So these are the classification, and let me start discussing the types of burnt brick according to their suitability. First, their classification is classified as first class, second class, third class, and the fourth class. In first class, the nature of brick is about sound, well sounded, well burnt, rectangular, then clean. Surface texture is clean, smooth, and no cracks are available. Then hardness, that is very hard. Suitability, it can be used for in face work of buildings and the monuments. Then second class bricks having the nature well burnt but with the irregular shape. The shape is not uh, is correct, or we can say it is not a perfectly rectangular in shape. Then surface texture is spots available on the surface. Then hardness, that is hard, it is lesser harder than the first class bricks. Then it is ordinary used in a building works for the cheaper construction. Then third class, that is unburned, or it is also called as underburned. Then surface texture is rough and distorted edges, it is not a perfectly shaped. Then hardness, that is slightly softer than the second class brick, it is used in building, not suitable for the heavy rain works. Then fourth class brick, it is also overburned, irregular in shape, very hard. It can be used as a road metals and as a aggregate replacement over the aggregate. Then foundation concrete as a railway ballast. So this is the classification according to their suitability. The next, suitability of burnt clay bricks. As we discussed earlier, where we can use the burnt clay bricks. Then special bricks. These bricks are used for the special purposes such as resisting to the action of chemicals, then chemical plants for engineering purposes to take a heavy loads, for refractory furnaces to withstand the large temperature. So the special bricks are used for the special construction works like a chemical factories and all. Okay. So the first type, that is acid resisting bricks. These acid resisting bricks are necessary for the chemical industries. Bricks required for the construction of buildings for the chemical plants are usually made from the mixture of refractory clay, feldspar, some from the silica such as a white sand and flint. The even alluvial soil can be utilized. So these type of bricks are the special type of bricks which are manufactured by using the some of the other material like a feldspar, then silica, okay, then clay, white sand and flint. Then acid resistant bricks with the water absorption less than 1% will not be attacked even by most concentrated acid. Okay. Then for manufacturing of acid resisting bricks, clay containing a high percentage of silica, that is about 80%, and low percentage of the lime and iron 1.5% maximum should be preferred. The acid resisting capacity of these bricks are depends upon the firing temperature. So that is a use of acid resisting bricks. Then engineering bricks. Engineering bricks are those which are heavy working bricks, can bear heavy loads. That's why it is called as engineering bricks, which are more vitrified than common clay building bricks. Engineering bricks are fired up to the stage where the pores are filled up with the fused material. Hence, they are less porous and absorb less water when soaked in the water. Then these bricks are used for paving purposes. They have a sufficient resistance against the impact, abrasion, and having a good strength and water absorption of these bricks depend upon the compound and sorry composition and the firing temperature. The high strength bricks are can be obtained from the alluvial soils. Okay, so the temperature is around 1060 to the 1120 degrees Celsius. Then silica bricks, quartzites, sandstone or the silica sand contains about 95% of silica. These are the uh, chief constituent used in the making of silica